Hi everybody. I will present today on a quick overview of SYCL. I guess it's a kind of speed dating because at the end I don't want to be only one in my room, so it's try to convince you to after do a little more deep dive on SYCL. So Yassi told me to do one slide on me. So I come from this red point, Rainier Island. Blue is Chicago, and in green is the antibody of Chicago. So I think I am the guy who come from farther. I think only the guy from Perth is somebody from Perth here. He go farther than me. I check. Sorry for the Sri Lanka people, and I'm still go farther than you. So I'm the member of the performance engineering team. I'm focused on runtime. This is what I do. My study on OpenMP runtime, SYCL runtime, level 0, and everything. And for this story, I think maybe the most important point is I'm the Argonne representative to the SYCL committee. So every week we have the SYCL working group, and we go there and we discuss new idea, and we try to move the SYCL specification forward for HPC user. So what is SYCL? So SYCL is a specification. So it's just a big document with a description of the language of the library, and it is done by the Kronos group. So the Kronos group is something who deal with open source specification. So for example, they do OpenCL, Spear, Vulkan, OpenGL. So it's really a lot of people are participating to this working group. It's not only one particular entity. SYCL, it's a C++ 17 API, so sorry for the Fortran people, it is really deep into C++. It's pure C++, so it's not like CUDA where they add this horrible triple bracket or this kind of thing. It is pure C++, no language extension, no pragmas, no attribute. But on the other hand, you have a lot of templates, a lot of lambdas, and all this kind of thing. It borrows some concept from OpenCL. OpenCL was really successful in C and everything. So we keep the same concept in SYCL. So it's nothing to do with OpenCL, it's just a concept. So platform, device, and all this kind of thing. It is single source. So like, for example, OpenMP, that's the difference to CUDA, for example, where you need to write your kernel and your language and your API in two different things. And it is portable. We have multiple backend. We'll show a slide later. So you can run on with a heap backend, with a CUDA driver backend, with a level 0 backend. So it's as possible as OpenMP. So we'll go over far more example inside the hands-on and let you compile and everything, but this is how code look like. So you see, it look like really like C++. So here you create a queue. A queue is like a little bit for people who do CUDA, like a stream. Some different exist, but whatever. You have some introspection in the object. From the queue, you can go to the device, and from the device, you can have some information. So for example, you can know the name of your device and everything. Then you can allocate some memory. Here we allocate shared memory. So it is a memory who can be read from the CPU and the GPU. And you can here, it's not like C where you malloc with size of. Here you have some template where you can say, okay, I want int. And then you use Lambda to submit a parallel for and to be able to, for example, here we initialize the array, we just allocate. In SYCL, everything is asynchronous for performances. So here we need to wait to synchronize the stream, or more exactly to synchronize the event. And then you can print it. So this thing is really a hello world of SYCL, so you see it's pretty dense. Of course, it's HPC ready kind of, so we have far more example. We can use reduction, which is really important for HPC. We can use atomic for the people who don't care about performance. We can have linear algebra, 1MKL. So here, for example, I show you an example of the 1MKL. So here we create a queue, and after, as usual, where before you were calling your gem, the only difference is at the beginning you pass the queue, and the queue will say, okay, I want to execute my kernel inside this gem. Also, I think something we work, and it was really a collaboration between Argonne and the SYCL community, is to have like interoperability. So that means from a CUDA stream, for example, you can create a SYCL queue, or for the SYCL queue, you can get the CUDA stream. It really allows you to port your code step by step, or if one day you find that SYCL is slow, you can just port this really particular code, this really particular pattern you have, go back to CUDA or to other level 0 or whatever to get the maximum performance. So I think it's really a big plus is to be able to be interop between SYCL and the backend. You can, of course, mix OpenMP and SYCL with some Canva. Don't try to call an OpenMP kernel with a SYCL. It will not work, but you still can have in 2 different translation units and all this kind of thing. It will work perfectly. So I say that SYCL is an API, is a specification. So we need people to implement this specification. We have mostly 3 implementation, now 2. We have Intel, where the Intel implementation of SYCL is called DPC++. DPC++ have multiple backends, so that means you can install DPC++ and it will run on multiple hardware. For example, it will run on level 0 for Aurora. Level 0 is a little bit like our CUDA driver, same level. Or you can run on NVIDIA GPU. They will use CUDA driver to talk to the GPU, or HIP also. I think they have a HIP backend. So DPC++ will have a HIP backend. So this one is the Intel infrastructure. On the other hand, we have more academic implementation of SYCL, which is called HIP-SYCL. It's from Germany. And same thing, they have an offload to OpenMP. So if you want to run on the CPU, but also a GPU backend with HIP, they focus more on HIP, on CUDA also, and also experimental level 0 backend. So that means you can play with 2 different implementations if you want it. On our system, we only deal right now with DPC++. We didn't install yet HIP-SYCL. As Brian told before, you have some tool to port your CUDA code from SYCL, to SYCL. It's called Cyclomatic. Before it was another name. I think it was a DPC++ compatibility tool or something like that, but they changed. We have Habi here. We have a lot of experience using this thing. And you can translate like million line of code because, you know, it would intercept well with CMake and everything and after translate everything. So it's not really an automatic translation. It's really more helping you. Sometimes you may need to code a little bit, but it worked pretty well. It even translates code to BLAS and all this kind of thing. So it's pretty nice to get you started as a starting point. Of course, we need to discuss about performance. At the end, it is really matter. A little controversial take just to get you a little bit excited. In my view, SYCL and CUDA runtime. So CUDA runtime is a CUDA you write with what is called CUDA. It's at the same layer of abstraction. Both of them will call CUDA driver. So at the end, you have no reason that the performance should be really different for the runtime. I mean, minus some poor implementation in one of the other and maybe some subtle differences. But in reality, you sit at the same layer of abstraction. And the code generation of kernel at first approximation is far less important than having a good runtime. Saying that, I think they are quite old results, but at the end of the day, if you go to the session, we'll put your slide here when we can compare. Here on top is Babel stream. So you see in blue, here is CUDA, and after is SYCL on A100. And you see the performance are really same. A little problem with dot, but I think we fixed it. It was a little problem. Lulesh, a few bit of performance, but at the opposite, for example, for D/, the SYCL version is faster than the CUDA version. So I don't want you to look too close as those results because doing apple-to-apple comparison is really hard. It depends on the version used, what kind of optimization. I just want to give you a feeling that they are similar in performance. At least in a fundamental level, you should not expect many differences. After we can discuss more, but so it's pretty valid in a performance-wise. So maybe a little pro cons of SYCL for you to know if it works with your project or not. So pro is really close to C++. So if you like C++, you will like SYCL. It's also a cons. If you are a Fortran developer, I think you will not like SYCL because it's pretty C++. You make one error, everything is templated, and we have like 1,000 line long of warning message. But it's backed by industry. As you see, Intel is pretty involved. They are not the only one, but Intel is pretty involved in the DPC++. So, and Intel is a big company, a lot of manpower, so a lot of bugs are evolving and be fixed pretty rapidly. It's portable, as we showed before. It's run with heap, a heap backend, a CUDA driver backend, level 0 backend, an OpenCL backend, an OpenMP backend, and it is deployed here and at NERSC too, and maybe at other, I don't remember already correctly. I think it's pretty simple compared, for example, to, at least in my view, to Cocos. It's like a thin layer on top of C++ and on top on things, so I think it's not too hard. And performance, at least if it's not performance, please talk to me and we'll fix it. We'll try to fix it at least. And in cons, maybe Intel is really big on SYCL. You never know. Maybe they will abandon it at a few later. But so some people are a little afraid of that. But as I say, no, everything is open source. A lot of other contributors in Kronos and everything. So at the beginning, I was a little afraid about that. And now I feel a little more confident that SYCL is here to stay. So what you will learn if you come with me this afternoon, enough SYCL to get you started on your project, enough SYCL to know if it is a good fit for your project, and maybe more importantly for your team, your group. So we'll go over some example and a lot of hands-on. It will be not really scripted. We'll do whatever you want us to do. We have some nice documentation that Abby wrote here, and I put all the example in this repo. And I think this is the end of my little speed dating talk. So any question?
Any questions for Thomas?
Yes.
Speaking of SYCL's kinship with C++, I'm wondering, I've run into projects like depending on Boost, things like that. Would those tools still be available? Yes.
Yeah, it's a good question. So it's pure C++, so you can interface with whatever C++ magic you want. So for example, Boost or whatever, it will work out of the box. So no, it's just, so for example, HipSYCL is just a C++ library, so it will interface perfectly with any C++ thing. Thank you.
Thanks to our speaker, Thomas.